10.4 goes over inverses of functions. When we are looking at these, the first thing that we're going to do is look at our inputs and our outputs, our x and our y values. Your input's always your x value, your output's always your y value. These inverses of these relations just means that your x becomes your y and your y becomes your x. So you're just switching the ordered pairs that you have. So if we look at the first example, it tells us to find the inverse of each relation. For example, A, it gives us the ordered pairs of -4, 7, -2, 4, 0, 1, 2, -2, and 4, -5. In order to find the inverse of these, we're just going to switch each of these values within the ordered pairs. So instead of your first ordered pair being -4, 7, it's going to be 4, -7. Oh, sorry, 7, -4. So switch them, and then you're done. For -2, 4, switch them. You have 4, -2. For 0, 1, again, switch them. It becomes 1, 0. For 2, -2, switch them. It becomes -2, 2. And for 4, -5, we switch them. It becomes -5, 4. For example B, we are given an input and output table. In order to find the inverse of this relation, we again are just going to switch your input and your output. So you can keep the input up top. You can keep the output on the bottom. Instead, you are just going to have your input be 5, 10, 15, 20, 25, and 30. For your output, you're going to have -1, 0, 1, 2, 3, and 4. For example C, we're given the ordered pairs of -3, -4, -2, 0, -1, 4, 0, 8, 1, 12, 2, 16, and 3, 20. Again, we're just going to switch the x and the y values from each ordered pair. So our inverse is going to be -4, -3, 0, -2, 4, -1, 8, 0, 12, 1, 16, 2, and 23. For example D, we're given an input and output table once again. So in order to find the inverse of this, we're going to keep the input up top, output on the bottom. Our input values are going to be our original output values. So it's going to be 4, 1, 0, 1, and 4. Our output values are going to be our original input values. So it's -2, -1, 0, 1, and 2. The next section within our notes, we are going to be writing a formula for the input of a function, and then we are going to be using an output in order to solve for a specific value. So with these, you want to keep in mind a couple things. First is the fact that f of x is the same exact thing as y. So when you start these, rewrite your formula or your function in terms of y instead of in terms of f of x. From there, it tells you to solve for x and then plug in a value for y. Output and y are the same thing. So output y and f of x, g of x, h of x, anything of x are all the same thing, and they all mean y. So if we look at example 2a, we're given the function f of x is equal to 2x plus 1, and then we're told that the output is going to be -3. So the first thing we want to do is we're going to change the f of x to be y. So I'm going to just rewrite this as y is equal to 2x plus 1. From here, we're going to solve this equation for x. So we're going to subtract 1 from each side to start with. We have 2x is equal to y minus 1. We then divide each side by the 2, and we get that x is equal to y minus 1 all over 2. This negative 3 is going in for y. So we're going to plug that in and simplify. So it's going to be negative 3 minus 1 over 2. Negative 3 minus 1 gives us negative 4 over 2. And negative 4 over 2 gives us that x is negative 2. For example B, we're given f of x is equal to x minus 6 with an output of 4. So again, we're going to first change the f of x to be y. So we have y is equal to x minus 6. From here, we're going to solve for x. So we just add the 6 to each side. We get that x is equal to y plus 6. And then we take the 4, we plug it in for y, and we get that x is equal to 4 plus 6, which gives us x is equal to 10. For example C, we have f of x is equal to 1/2 x plus 3 with an output of 4. So for this one again, change the f of x to be y, then solve for x. Move your 3 over by subtracting it from each side. You have 1/2 x is equal to y minus 3. From here, multiply each side by the reciprocal of the 1/2, which is 2. This is going to give us x is equal to 2y minus 6. Take the 4, plug it in for y. We have x is equal to 2 times 4 minus 6. 2 times 4 is 8. 8 minus 6 gives us that x is equal to 2. For example D, we have f of x is equal to 4x squared with an output of 4. Again, change the f of x to be y. So you have y is equal to 4x squared. From here, solve for x. In order to solve for x, you're going to have to divide each side by the 4 to start with. So you have x squared is equal to y over 4. You want x, not x squared. That x has a power of 2 on it, so take the square root of both sides. Remember, when you're doing this, you are putting a plus or minus in front of your answer. So you're going to have x is equal to plus or minus the square root of y over 2. We're told that our output is 4, so plug the 4 in for y and simplify. So you have x is equal to plus or minus the square root of 4 over 2. The square root of 4 is 2, so x is equal to plus or minus 2 over 2, which gives us that x is equal to plus or minus 1. The next part of this lesson goes over finding the inverse of functions. When you find the inverse of a function, you're going to change the f of x to be y. Then you're going to switch x and y and resolve for y. When you resolve for y, when you get your final answer, you're going to label your function as f to the negative 1 of x instead of y. That indicates that it is the inverse of another function. So if we look at some examples, we're not going to be graphing these, but we are going to find the inverse of each. So, for example, 3, we have f of x for a. We have f of x is equal to 4x minus 9. First step, change f of x to be y. So this gets rewritten as y is equal to 4x minus 9. Next step, change x and y, so switch them. So you're going to have x is equal to 4y minus 9. From here, solve for y. Add your 9 to both sides. You have 4y is equal to x plus 9. From here, we divide each side by the 4 to get y by itself. You have y is equal to x plus 9 over 4. To indicate that this is the inverse of the original function, we write it as f to the negative 1 of x is equal to x plus 9 over 4. For example B, we have f of x is equal to 6x. Remember, first step, change the f of x to be y. So y is equal to 6x. From here, switch your x and your y. So we have x is equal to 6y. Now resolve for y. Divide each side by the 6. You have y is equal to x over 6. This does not indicate that this y is equal to x over 6 is the inverse. So rewrite this as f to the negative 1 of x is equal to x over 6. For example C, we have f of x is equal to negative x plus 5. So again, we're going to rewrite this as y is equal to negative x plus 5. From here, we're going to switch x and y, so it's going to be x is equal to negative y plus 5. Now solve for y. You can move the 5 over by subtracting it from each side. You're going to be left with negative y is equal to x minus 5. From here, divide each side by a negative 1, so that changes the sign on everything. So we have y is equal to negative x plus 5. We rewrite this as f to the negative 1 of x to indicate that that negative x plus 5 is the inverse of the original function. For example D, we have f of x is equal to 1/4 x minus 1. So again, we're going to change the f of x to be y. We have y is equal to 1/4 x minus 1. Next, we switch our x and y to have x is equal to 1/4 y minus 1. And now we're going to solve for y. So we add the 1 to both sides. We're left with 1/4 y is equal to x plus 1. In order to get rid of that 1/4 in front of the y, we're going to multiply each side by the reciprocal of that. So the 1/4 and the 4 cancel out. We have y is equal to, distribute that 4 in, 4x plus 4. We rewrite this as f to the negative 1 of x is equal to 4x plus 4. For our next example, we're just still finding the inverse of these. So again, change the f of x to be y, switch x and y, and then solve for y. For example, for A, we have f of x is equal to x squared. We're going to change the f of x to be y, so that's y is equal to x squared. From here, switch your x and y, so x is equal to y squared. You want y, not y squared. So take the square root of both sides. We're going to have y is equal to plus or minus the square root of x. So this gives you two functions. One that is f to the negative 1 of x is equal to the negative square root x, as well as f to the negative 1 of x is equal to the positive square root x. So you have two functions with these. For example B, we have f of x is equal to negative x squared. So for this one, again, change the f of x to be y, then switch your x and y, resolve for y. For this, we're going to have to divide each side by the negative 1 first. So we're going to have negative x is equal to y squared. From here, we're going to take the square root of both sides. We're going to have y is equal to plus or minus the square root of negative x. This tells you that you're taking the square root of a negative number regardless. Because there's a negative underneath there is no inverse. Where is it? There it is. Example C, we have f of x is equal to 4x squared plus 3. For this one, we're going to change that f of x to be y. We're going to move the 3 over by subtracting it. We're going to switch x and y. So x is equal to 4y squared plus 3. We are going to subtract 3 from each side, and you have 4y squared is equal to x minus 3. From here, you divide each side by the 4. You have y squared is equal to x minus 3 over 4. You're going to take the square root of both sides. So you're going to have y is equal to plus or minus the square root of x minus 3 all over 2. You can leave it this way, but just remember to make sure that f to the negative 1 of x is equal to plus or minus the square root of x minus 3 all over 2.